Welcome grade 7 to a going over of the answers from the review exercise unit 9. Again, this is completely optional video, but for those of you who may have been stuck on some of these questions, this may help you at one point or another. So the first set of questions that we have on this review is we're given a sequence of numbers and we're asked to find the next two terms in each sequence. In other words, we need to figure out a little bit of a pattern here in order to find out what the next two values or what the next two terms are going to be. So our first one, 1a here, we're given the sequence of 25, 27, 29, 31. We're asked to figure out the rest. What I can see is that this pattern has numbers that are increasing in value. And so my first step is going to be to see, are they increasing at the same rate? So here 25 to 27 plus 2, 27 to 29, I'm going up by another 2, going up by another 2. So I seem to have found a bit of a pattern or a rule here. So if I carry through this pattern for the next two terms, 31 plus 2 is going to give me 33. And then plus another 2 is going to give me 35. And I have my next two terms here, 33 and 35. Let's go on to B now. We're given the number sequence 41, 35, 29, and 23, and then asked to figure out the next numbers in the sequence. Now this one's not increasing anymore, we're actually getting smaller, so let's see if it's getting smaller at the same amount or the same rate. So from 41 to 35, I'm going down by 6, and here I'm going down by 6. It seems like we're finding a pattern here, going down by 6. So if I continue that, going down by 6 here, I'm going to get to 17 as my next number. I decrease by another 6, and I get 11 as my final term here. So I have term 5 and term 6, the next two numbers within this sequence. C. C gets a little bit trickier. We're given the numbers 1, 4, 16, 64, and then we have to figure out the next terms here. We see that it's an increasing pattern right off the bat, but this increasing pattern is a little bit more complex because it's not going up by the same amount. We can see that right away. As soon as we start, we get the numbers 1 to 4, which is adding 3 to it. But going from 4 to 16 is up another 12. So we're not going up consistently by just adding. So let's see if there's something else that we're increasing by, maybe by multiplying. So 1 to 4 is multiplied by 4. 4 to 16 is also times 4. 16 to 64 is also times 4. So we seem to have found a bit of a pattern here. So if we carry through that pattern, 64 times 4 would be 256 times 4. And times another 4 here from the 256 would give us 1024. So these are our next two terms within this sequence, 256 and 1024, as we multiply by 4 to get to those next terms. D gets even more complex. So for D, we're given the terms 5, negative 10, 20, negative 40, ... So if you remember in a previous video, we talked about how whenever we switch back and forth from a positive to a negative, and we keep doing that, one, we know we're multiplying or dividing, and two, we know that the number that we're multiplying or dividing by has to be a negative number. So I'm not increasing by the same amount or decreasing. To go from 5 to negative 10 would be a minus 15, but then negative 10 to 20 is a plus 30, so that doesn't fit. So 5, what can I multiply by 5 to get to negative 10? And I can multiply it by a negative 2. And negative 10 times a negative 2 gives me positive 20. Times a negative 2 gives me negative 40. So I found my pattern here. If I multiply negative 40 by negative 2, I'm going to get positive 80. If I multiply that by a negative 2, I'm going to get negative 160. So these are my next two values within my series. They are 80 and then negative 160. So those are all the questions in number 1. For number 2, we are given a general term and we're asked to find the value at term 3 and term 20. So for number 2 here, we are given Tn, or the term number, equals n times n plus 2. Figure out T3 and T20, okay? All we need to do is plug in 3 for our n values, solve that, and then plug in 20 for our n values and solve that. So let's do T3 first. T3 is going to be 3 times 3 plus 2. We do our brackets first, 3 plus 2 first, which is going to give us 5. So T3 equals 3 times 5. 3 times 5 is just going to give us a value of 15. That's our first term there. And if you see in your answers, you actually have two values that have T3 as 15. So we do have to keep going here to figure out what T20 is going to be. T20 is going to be 20 times 20 plus 2, or T20 is 20 times 22. And all we need to do is simply plug that into our calculators to figure out what our final value of T20 is going to be, which is 440. So you now have your T3, you have your T20, and you have your answer for that particular question. Number 3 gives us a little bit of a different or a strange type question here as well. It says if the general term, so it's given us the general term again here, but if the general term for a particular question is Tn equals 1 over 2n plus 1. Find the sum, remember that sum means adding, of the first 3 terms. So not only do I have to figure out what the first 3 terms are, I then will need to add those 3 terms together to figure out what my final answer or value is going to be. And as you can see through the answer options, it's not going to be a nice fun answer. We're going to have things that get a little bit messy here. So let's figure out our term. Term 1 is going to be 1 over 2 times 1 plus 1. Or T1 is going to be 1 over 2 times 1 is 2 plus 1 is 3. So 1/3. Not too tricky to start. Let's do T2. T2 equals 1 over 2 times 2 plus 1. T2 equals 2 times 2 is 4 plus 1 is 5, so 1/5. And then T3, our final one here, is going to be 1 over 2 times 3 plus 1. T3 equals 1 over 6 plus 1, which is 7. So now the only thing I have left to do is to add 1/3 plus 1/5 plus 1/7. Now the reason why this gets a little bit messy is these are all prime numbers, which means that we're not going to have anything fun that these all go into or anything simple that these all go into. So in order to figure out what values we're going to need to use here, we actually have to multiply them all together. We have to come up with a common bottom number, which is going to be 105. And remember, once I have that common bottom number, I can just write it straight across the top. That doesn't change. It's only our top numbers that are going to change. The top number here is going to be 35. The top number here is going to be 21. The top number here is going to be 15. All I have left to do is add together the 35 plus the 21 plus the 15 to give me a top value of 71 with a bottom value of 105. Unfortunately, that can't really be simplified, so that is our final answer for the sum of the first 3 terms for that question. Let's move on to number 4. In number 4, it gives us a series or a sequence of numbers, but we need to figure out the general terms. Now, what's nice here and something to remember is that you're not just coming out with this out of the blue. You are given 4 options to choose from. Use that to your advantage. Take a look at the ones there and see which ones make the most amount of sense. So, for example, in 4a, we're given the sequence 2, 3, 4, 5. And so we see that it's a simple increase by 1, but we have lots of values here to go off of. So what I would say is try them. Try the first value. If n is 1, which ones will give us the value of 2? Well, the first one would be 2 times 1 plus 1. That would give us a 3, so that one doesn't work. The second one is 1 plus 1. Yeah, that one does work, but we have to check to verify that the other ones don't as well. There might be some that work for the very first term, but we might have multiple that work, and it's the second and third term that might determine that. The second one, let's see, 1 plus 2, that's 3. Nope, that doesn't work. The third term, 2 times 1 plus 2 equals 4. No, that one really doesn't work. So the only other option that works for this value is Tn equals n plus 1. And you can always verify with the other ones as well. So if we put 2 in there for the second term, would we get the answer of 3? Well, 2 plus 1, yeah, it is 3. What about the third term? 3 plus 1 is 4? Yep, okay, it works. And you could keep going, you could verify for all the rest. But for now, Tn equals n plus 1. That's the general term for that question. The next one gets a little more complicated. We're dealing with exponents here. We're dealing with a lot more. We have 2, 6, 18, and 54. So let's first see which of these values we can fit in order to get the first value of 2. Well, the first one is 3 times 1 minus 1. 1 minus, or to the power of 1 minus 1. It's actually n minus 1, but I plugged in 1 for the first term there. That's 0. Anything to the power of 0 is 1. It's not 2, so that doesn't work. The second one, 2 times 3 times, or 3 to the power of n plus 1, or 1 plus 1. 1 plus 1 is going to be 2. 3 to the power of 2 is going to be 9. 2 times 9 is 18. That's way higher than what we need. Option number 3. Tn equals 3 to the power of n plus 1. Okay, n plus 1 is going to be 2. 3 to the power of 2 is going to be 9. Too much. Nope. So really, I'm hoping that my last one works because there's nothing else left to do. And so let's figure this one out. So 2 times 3n minus 1, if I do 1 there for n, that would be 0. 3 to the power of 0 is 1. 2 times 1 is 2. So that does fit. And if I were to plug in the next values for 2 there instead, would I get 6? Well, let's see. 2 minus 1 is 1. 3 to the power of 1 is 3. 2 times 3 is 6. Yeah, it does work. And I could keep plugging away to figure that out. But for this one, I'm able to figure out that the fourth term, Tn equals 2 times 3n minus 1, is the general term for that particular sequence. Let's move on to our last and final question here, where we are given the values of 1/4, 2/5, and 3/6, and 4/7. We're asked to find the general term here using some of these fractions. Let's just plug in what we know. First one, let's see if I do 1 over, it says n plus 3. I'm going to use 1 plus 3. 1 plus 3 is 1 over 4. Yeah, that one does work. Okay, awesome. But we have to make sure that other ones don't work. So the next one is 1 over n minus 3, or 1 minus 3. That would be 1 over 2. Nope, that one's no good. The next one, n over n minus 3. Okay, 1 over 1 minus 3, which is the same as 1 over 2. Nope, no good. The next one, n over n plus 3. So n plus 3 would be the same as 1 plus 3, which would also give me 1 over 4. So wait a second, I have 2 correct answers here. That can't be the case. And actually, in this case, it's ones where I need to actually go to step 2 to see what my answer might be. So what if we plug 2 into our answer? Well, for this one, I would have 1 over 2 plus 3, or 1 over 5. That one does not work because my second value is 2 over 5. Here, I would have n, or 2 over n plus 3, or 2 plus 3, which would give me 2 over 5. So that means that this one is the winning value, my winning general term here, which is Tn equals n over n plus 3. It's my winning general term for that value. So hopefully that helps make sense and helps explain some of these questions as you work through your review exercise.